Simplifying square roots. In order to understand how to take the square root of a number, first you have to understand perfect squares. This is something that we've learned quite a bit about over the last several weeks as we've been graphing quadratic functions. For example, 1 squared is 1, so 1 is a perfect square. 2 squared is 4, so 4 is a perfect square. 3 squared is 9, so 9 is a perfect square. 4 squared is 16, so 16 is a perfect square. 5 squared is 25, so 25 is a perfect square. And as you can see, the list goes on. If you understand what perfect squares are, then square roots are actually very simple. Here's a few examples. Number 1, square root of 9. Well, we know that 3 squared is 9, so that tells us that the square root of 9 is just 3. Number 2, the square root of 49. We know that 7 squared is 49, so that means that the square root of 49 is just 7. And number 3, the square root of 81. If we look at our perfect squares list over here, we know that 9 squared is 81, which tells us that the square root of 81 is just 9. Now these 3 examples are pretty straightforward, very easy, because we were dealing only with perfect squares. But let's take a look at a few more. Number 4, the square root of 20. 20 is not a perfect square. Off the top of my head, I don't exactly know what the square root of 20 is. I could type it into the calculator and I would get a decimal, but what I want you to be able to do in this unit is to simplify the radical. So if I don't know exactly what the square root of 20 is, then what I'm going to do is I'm going to break it down into a product of 2 numbers where I do know what the square root is. For example, with 20, I know that 4 times 5 is 20. So if I break this down to the square root of 4 times the square root of 5, this is the same thing. Square root of 4 times the square root of 5 is the square root of 20. But I didn't know the square root of 20. I do know the square root of 4. The square root of 4 is 2, and that leaves the 5 under the radical. So 2 square root 5 is the exact same thing as the square root of 20, but it's been simplified. Let's do the same thing on number 5. Square root of 45. I don't know what the square root of 45 is, so what I want to do is break it down into a product of 2 numbers that I can actually take the square root of. So look at your list over here of perfect squares. What number goes into 45? 9. 9 times 5. So I can break this down into the square root of 9 times the square root of 5. And even though I don't know the square root of 45, I do know the square root of 9. The square root of 9 is just 3. So that leaves me with 3 square root of 5. Now the last example is a little trickier. You have 180. The only thing that makes this one more complicated is you've got a pretty big number. But again, what we want to do is we want to find the square root of 80, and if I don't exactly know what the square root of 180 is, I want to use one of the numbers on this list so that I can take the square root. So let's see what goes into 180. Looks like 180 is divisible by 4, so I could think of this as square root of 4 times square root of 45. But remember in the previous example, we already broke down 45, so I know that one can be broken down further, so I'm going to mark that off my list. Let's try a bigger number. Let's see if 180 is divisible by 9. And it is. 180 is divisible by 9, so I could write square root of 9 times square root of 20, because 9 times 20 is 180. But we actually already did square root of 20, so I know that one can be broken down quite a bit more also. So I'm going to mark it off my list. I want to find the largest perfect square that goes into 180. Now think about if 4 goes into 180, and if 9 goes into 180, 4 times 9 is 36. So I bet 36 also goes into 180. Let's try that one. 180 is divisible by 36. I can break this down into the square root of 36 times the square root of 5. 36 times 5 is 180. And even though I don't know the square root of 180, I do know the square root of 36. Square root of 36 is just 6. And that leaves the 5 inside the radical.